look at our next prompt. And here's the prompt. It says here that you are 36 miles from a friend. You both start riding your bicycle towards each other at the same time. You travel 15 miles per hour and your friend travels 3 miles per hour slower. How far will you travel before you meet your friend? Okay, so did you read that problem carefully enough? Okay, and I'm going to start asking some questions. And like always, I will always start by drawing some pictures. It helps when you have a distant rate times time problem like this. Oh, I'm sorry, just do that. Okay, let's draw a picture. This is you. This is your friend. Initially, both of you are exactly how many miles apart? 36 miles apart. Okay, you see how important that is to have this picture right there to show exactly what's going on? And you also know about the problem is that what's happening to the two of you? Are you walking away from each other? Okay, or riding bike towards each other. So, if you're going towards each other, do you know your speed yet?
Yes.
Yeah. How fast are you going?
15.
Ah, you're going at 15 miles per hour. And your friend, how fast are your friend going?
12.
Did the problem say exactly 12?
No.
But where do you get that 12 from?
3 miles less.
Very good. You have to interpret. That's what I'm saying. You got to interpret problem. You can't just assume anything. The problem tells you that your friend's going 3 miles per hour slower than you. So therefore, your friend is only going at 12 miles per hour. So at some point in time, you two will meet, right? But why is it I'm drawing the red line longer than the green line? Makes sense, right? This makes sense that because you're going faster, therefore you have more distance to cover. And you will likely meet your friend over on his side and your side. Imagine this is the halfway mark. You will definitely gonna go past that halfway mark based on how fast you travel. Okay, does it make sense? All right, so I'm gonna jot down some information as well. You are going at 15 miles per hour, and your friend now, he's going at 12 miles per hour. Okay, what else is given in the problem? Anything else given?
You're going at the same time.
Oh, I bet a lot of you will actually overlook that information because you don't see I give you a number for time. Usually I'll say, yeah, you will be 5 hours on the road or 1 hour or whatever, or you spend 15 minutes more or took off ahead or whatever. But this time I just said this, that you took up at the same time, right? At the same time. So the time that you and your friend start riding towards each other are the same. Imagine that you have another friend being the observer, looking at what happened and have a stopwatch right there. This time will apply to just your friend, you, or both. Both. That's what it means. Okay? So in other words, the time here, I should use the red for this. The time here versus the time here should be the same. It's not going to be different. Okay? So why is it so important to have that? Well, think about this. The question asks you what? What is the problem asking you to find? How far did you go before you meet your friend, right? But then if you think about this, if you declare how far you go, then the distance requires to have rate times time. Remember I told you that you always have to start with this one right here too to start thinking about. If it's asking you about the distance that you go, but distance requires rate times time. You have the rate, don't you? But do you have the time? So basically we have two unknown things. Distance we don't know. The time we don't know. In this case, however, instead of declaring two variables, I can only declare one. Reasons because you guys both share the same exact time. There's no different in time. So in this case, however, you just say t represent the time that you and your friend on the road. applies to both of you. So notice instead of declaring two separate t's, I do not do that because they're technically the same t, right? Same time. And you're saying, wait. The problem asks you about the distance. Why didn't you declare the distance you travel and distance your friend travel? But then you got to go back and I said something like this before. I said 99% of the time, you can technically use that last question to declare your variables, right? But then there's that 1%, and this is the 1%. This is the 1% where you have to think deeper in that and say, wait, if I need to know the distance, I need to know the time first. And because the time applies to both of us, well, I just declare one variable that represents for the both of us. So, think about this carefully. If we have the rate, and technically we just declare time for both. Rate times time will give you what? See, you got to know that formula by heart. What is rate times time going to get you? The distance. Won't this give you the distance that you travel? Notice I put a small y to represent you. Is that true? So, rate times time will give you the distance you travel. And likewise here, if you take 12 times t for your friend, what would that give you? Yes, the distance that your friend travel. So I hope you see what's going on here. If you have your distance and your friend distance, and you are exactly 36 miles apart, how do you actually tie everything together? What do you think? If your distance here and your friend's distance right here, what do you do with the two distances? Yes?
You add it together to form 36 miles.
So is it fair to say this? 15 times t, which is your distance, plus 12 times t, which is your friend distance. Why am I using the same t? Because you are leaving at the same time. That's why. But if you take the two distances and add them together, you have 36. Distance, distance, distance. And notice the reason we don't need another equation is because we only have one variable. The only time we need two equations when we have two variables, right? In this case, since we only have one, we only expect to have one equation. And as you can see, what's 15t plus 12t?
27.
27t equals to 36. If we divide by 27 both sides, t is what? 1.3. Can we write like this? 1 and 1/3.
Yeah.
What's the unit of time in this case?
1
Hour, right? Or if we want to convert that, we can write it as 4/3 of an hour, right? Is that true? 1 and 1/3 is 4/3. True? But did your answer the actual question? No, the question asks, how far did you go? But look, didn't we declare this is the distance that you went? 15 times t? If we know what t is, guess what we're going to do next?
Plug it in.
Plug it back in. You're right. So we'll take that, plug it right back into your distance, which is 15 times 4/3. What is 15 times 4/3? 20. 20 what? 20 what? Huh?
Miles per hour.
What is rate times time going to get you? So is distance measured in mile per hour? What does it be measured with? Miles. See, very careful as well. Distance times time is miles, right? And perhaps I should prove this to you once and for all. It is 20 miles that you travel. So if you travel 20 miles, how far did your friend travel? 16. Okay. So for those of you like confused, like, wait, which unit should I write? Think about this for a moment. This is 15 miles, right? So I just write the unit out for you to see. This is time, right? So rate times time. Sorry, miles per hour. And here is the time, which is also an hour. Watch what happened. You see how hours crossed out and you have mile left? That's why it has to be written like that. Okay, this is called dimensional analysis, by the way, for those who want to examine the unit. What unit should I put it in? But then again, if I say that this is distant, it's always going to be in, single unit of mile, kilometers, meters, and so on. Rate now will have 2 miles per hour, kilometers per hour, or meters per second, whatever. That's the rate. Because rate relates to ratio, and as you know, ratio has to have 2 things at one time, right? And of course, time is measured in hours, second, minute, and so on. So it's general knowledge that I want you to go after. Okay, so basically this is a problem. Any questions on this one? Shocking? No? Is it shockingly difficult or shockingly easy? I hope so, because like I said, every problem that you'll be doing has to do with this, right there. Distance equals rate times time. Okay? Alright, so we'll stop right there.